and welcome. And in this video, we're going to be doing some more absolute value inequalities, okay? So you can kind of think about this as a part two. So in this video, we're going to cover just a couple more complex problems, and we're also going to cover some of the special cases because I don't believe we covered any of the special cases in the previous video. So I want to take a look at some special problems. So let's take a look at a couple now. So we have an example here. We have 3 times the absolute value of 2x minus 5 plus 4 is greater than 19. So remember that the first step in any absolute value inequality problem and absolute value equation problem is to first isolate the absolute value. So let's go ahead and do that. So the first thing I got to do is I got to subtract 4 from each side, okay? I got to subtract 4 from each side, and that's going to get me 3 times the absolute value of 2x minus 5 is greater than 15, okay? From here, remember, we do not want to distribute the 3 into that absolute value. The reason that you want to is because with parentheses you would, okay? But think about what distributing is. You're multiplying. Instead, use its inverse operation, which is division. So I can divide each side by 3 instead of multiplying that 3 in, because it would make it a little bit more challenging, okay? So now we have the absolute value of 2x minus 5 is greater than 5, okay? And now that we have it isolated, we have to set up our 2 inequalities or a compound inequality, but we need to determine if it's an and or if it's an or compound inequality, okay? Now remember, since this is isolated and it is greater than, that means it is going to be an or compound inequality. So I'm going to set up my 2 inequalities now. So it's going to be 2x minus 5 is greater than 5, or 2x minus 5 is less than negative 5, okay? Now remember, what's inside the absolute value never, ever, ever changes, okay? Stays the same. The only thing that changes is the second inequality, and all you do, remember, is you flip the inequality symbol and you change the sign. You make it negative, okay? Now we move on to our next step, which is just to solve each of these, okay? So the first thing I would do is I would add 5 to each side, and I'm going to do both inequalities at the same time. Once again, you don't need to. You can do it separately if you want. So this is going to become 2x is greater than, that would become 10, or 2x is less than 0. And now, just one last step for solving these. We divide each side by 2. Okay, so that's going to get us x is greater than 5 or x is less than 0. So that is our solution as an inequality. But remember, I want you to practice with graphing this on a number line as well as getting it in interval notation. So let's go ahead and take a look at how we would plot this on a number line. Okay, so I got a blank number line here, and now I don't know if you've had teachers or professors that want you to draw like every single tick mark on a number line. I'm really lazy, so I don't care if my students literally just go, okay, 0 and 5, I'm going to call that 0, and I'm going to call that 5. I really don't care, okay, as long as you still graph it correctly. Because the way we would now graph this is, well, I'm looking here and I'm going, okay, x is greater than 5. It's not or equal to 5. It's strictly greater than. So I'm not using a closed circle. I'm using an open circle on 5. And since it's greater than 5, I can be all these numbers to the right of it, like 6, 8, 10, 1,000, a million, and so on. So I'd be shading all of the numbers to the right of 5. So all these numbers to the right of 5 would be solutions, okay? Now that's only part of it, because I also could be less than 0. X greater than 5 or x less than 0. And once again, it's not or equal to, so I'm using an open circle. And I can be less than 0, so I can be like negative 1, negative 10, negative 100, so on. All these numbers to the left. So that would be our solutions graphed on a number line, okay? But we also want to look into interval notation. We want to write our answers in interval notation as well. You really need to practice this, okay? Now remember, interval notation is you read all the solutions from left to right, okay? So I'm going from left to right. Well, this is going all the way to the left, and all the way to the left back over there is negative infinity. So this is going all the way to negative infinity, okay? And it starts at negative infinity, and it goes all the way up to 0, negative infinity all the way up to 0. And then it stops. And notice, I cannot be 0. It's not or equal to. And you can also never touch infinity. It's like always out of grasp. I can't grab it, okay? That's my attempt of grabbing infinity. Really lazy. So it always gets a parenthesis. Then it stops because it's or. And remember, in interval notation, or is denoted by this big fancy U for union, okay? We're lazy, deal with it, okay? Then it starts back up again at 5, and it goes all the way to the right, and all the way to the right over there is infinity. So it goes all the way to infinity, which you can never be. Remember, I'm trying to grab it really lazily. And I can't be 5 as well, because it is not or equal to. So this would be our solution. In interval notation, you always need to have it left to right, okay? It needs to be in this order. All right, so that is an example. That's fairly complicated as they can get. The only other way it can get more complicated is if you have to divide or multiply by a negative. Remember, then you have to flip the inequality symbol. So just be on the lookout for that. But it can also get challenging in the sense of special cases. So let's take a look at an example that will become a special case. Okay, we got a new example here. We have 2 times the absolute value of x plus 6 plus 9 is less than 7, okay? Now, remember, always isolate the absolute value first. So the first thing I'm going to do is I'm going to subtract 9 from each side. Okay, and once I do that, I'm going to have 2 times the absolute value of x plus 6 is less than negative 2. Okay, and from there, I have to divide each side by 2. So I'm dividing each side by 2, and I get the absolute value of x plus 6 is less than negative 1. Okay, and now this is where we take a step back, think about what compound inequality this would be. And remember, this would be an and compound inequality. Whenever you isolate the absolute value and it's less than or equal to, it's an and compound inequality. Remember, what's inside does not change, so we would have x plus 6 is less than negative 1, but is greater than and greater than positive. Wait, what? Yeah, this doesn't make any sense, okay? Think back to what absolute values actually measure. They measure distance. So what this is asking for is, hey, what numbers are less than negative 1, away from negative 6? That doesn't make any sense. Distance cannot be negative. Another way to kind of think about this is, well, what does an absolute value do? Well, it takes whatever's inside and makes it positive. So this side here is always going to be positive. This is always going to be a positive side, no matter what, okay? And is a positive side, or is a positive number ever less than negative 1? No, that's impossible. Positive numbers are always greater than negative numbers. So this actually is impossible. It cannot happen. And that's because this is no solution, okay? So this is no solution. Think about it. You can't have a positive number be less than a negative number. That kind of defies how we built our number systems, okay? So this is no solution. I personally would not graph this on a number line because it would just be a blank number line and your teacher would be like, what is this? So no graph, but you can also not really have it in interval notation. I personally would just kind of have it as this. This kind of shows no solution, okay? So that is a special case of when it will be no solution with an inequality. Remember, if you ever have an absolute value on one side and a negative number on the other side, that's where special cases come from, and that's where weird things can happen, okay? And I do want to take a look at another weird problem coming up right now. Okay, so in this problem, we have the absolute value of x plus 7 minus 2 all over 3 is greater than or equal to negative 5, okay? Remember, we got to isolate the absolute value. Now, you can't actually add 2 to each side yet because that's being divided by 3. In fact, everything's being divided by 3, so we got to get rid of that first. So the first thing we would do is to undo division is we would use multiplication. So I'm going to multiply each side by 3. And what that will now become is the absolute value of x plus 7, okay, the absolute value of x plus 7 minus 2 is greater than or equal to negative 15, okay? Now we can add that 2 to each side. So I'm going to add 2 to each side, And that's going to get me the absolute value of x plus 7 is greater than or equal to negative 13. Okay, and then once again, you would think about what kind of compound inequality is this. This would be an OR because it's greater than. In this case, it's greater than or equal to. But if it's ever greater than or equal to, it's an OR compound inequality. But once again, we should take a step back and think about what's happening here. Once again, we have an absolute value on one side. This is always going to be positive. This is always going to be a positive number. It could be 1, it could be 8, it could be 7.2, whatever. It's always going to be a positive number. Well, isn't any positive number always going to be greater than or equal to negative 13? Or in fact, greater than or equal to any negative number? And that's, yeah, it doesn't matter what we plug in for x. You can plug in whatever number you can think of in for x, and it's always going to work out. That's because it is all real numbers as a solution, okay? It is every real number imaginable, okay? So that would be our answer. And for that, once again, it would be on a number line, like just the whole thing shaded, so I'm not going to do that. But we can have that in interval notation. If you think about it, all real numbers, well, every single real number is from negative infinity all the way up to positive infinity, okay? So that's exactly what we're going to write, negative infinity to positive infinity. And that would be our solution in interval notation, okay? So that's solving absolute value inequalities. It really doesn't get much more challenging than that. So if you have any questions, feel free to let me know. I hope this video helped you out. And in the next couple of videos, we're going to be talking about graphing lines and inequalities and systems and a lot of good stuff. So I look forward to seeing you in those videos.